Okay, so welcome back. Now that we reviewed this box model or box method that we'll be talking about today, now we are going to talk about how instead of just using numbers, we're going to multiply polynomials using the box method. So if you flip to the back side of the worksheet you've been working on, these would be what the problems from this section would look like. So you can see number 1 says multiply each polynomial and write the product. So we have x plus 3 times x plus 4. So one thing to think about is this would be like the length and this would be like the width. So if we carry over from the previous example, x plus 3 could be broken into two parts, an x and a plus 3. And I intentionally put those on top of each of the little boxes because remember, ultimately we're going to find the area of the 4 boxes and then add them together. And so the width is the x, or the length, I guess. The other one is the x plus 4, so this box can be the x, and this one can be the plus 4. So just like we broke apart on the previous example, the 62 into 60 plus 2, and the 84 into 80 plus 4, this is actually a little more straightforward because it's already broken apart into parts for us. So we put the x on one box, the 3 on the other, the x on one box, the 4 on the other. And now, just like we did before, we're going to start just by finding the area of this upper left corner, which means we're doing x times x, which is x squared. Next, I'm going to find the area of the upper right-hand corner, which is x times 3, which would be 3x. So the area of just that green box is 3x. Then we're going to go to the lower left corner. We're going to find just the area of this blue box. And I have x times 4, so that's 4x. And last but not least, I'm going to find the area of the lower right-hand corner, or this purple box, which would be 3 times 4, which is 12. Okay, and then what we talked about is that the area of the whole box is what the area of these 4 added together would be equal to the area of the whole box. Okay, so remember, ultimately, to multiply these together, because we're doing length times width, we're finding the area of the whole red box. Now the one thing that's a little different is that in the last example we just had 4 numbers to add together. But now we have to think about adding like terms. So remember, when we combine like terms, anything that has an exponent, so like an x squared, could only be added together with things that have an x squared in it. So we only have this 1x squared. So my answer is going to go down here. So I have x squared. Now my next box has an x, or x to the first power basically. So I need to add everything together that has just 1x. So it's a 3x and a 4x. So those I'm going to add together. Now I'm going to circle that because they're on the diagonal together. And that's going to be a consistent thing we'll see. So I have 4x plus 3x. So I add the coefficients. So 4 plus 3 is 7. And I just keep the x attached. And then last but not least, I have this 12. There's nothing to add to it, so I add 12. What this means is that if I multiply x plus 3 times x plus 4, it is the same as x squared plus 7x plus 12. So you can see that I took 2 linear factors and turned it into a quadratic because it now has an x squared, and this is a quadratic in standard form. Okay, so why don't you pause the video and maybe try on your own for the next one, or if you need another example, follow along. So my one side of my box is going to be an x and a negative 1. So if we have minuses in there, you just bring it over as a negative. The top box here has a 2x with a minus 4. Again, I'm going to do the x times 2x. Gives me 2x squared. Then I'm going to do a negative 1 times a 2x. That gives me this box is negative 2x. And then I'm going to do x times negative 4 is negative 4x. And last but not least, I'll do negative 1 times negative 4. 2 negatives makes a positive. 4 times minus 4. Last but not least, I add like terms. Again, that upper left corner box. And so I'm adding together these 4 boxes within the bigger box. I have the 2x squared, nothing to add that to. And now once again, I have a negative 4x and a negative 2x. The 2 things that are like terms that I need to add together lie on this diagonal together. And a negative 4 plus a negative 2 is a negative 6x. And then plus the 4 on the end. Okay, so I have that on the end. Alright, so now that you've seen one example with all pluses, one with some negatives, again, if you needed help on the last one, I do want you to try to pause it now before you watch the video on number 3 so you can see if you're getting it. Hopefully what you did is you got a 4x and a plus 5 on one side, an x and a minus 2 on the other. Now one thing I didn't bring up before is it doesn't matter which side you put them on. I could have put my 4x and my 5 here, my x and my negative 2 here, and I would get the same thing. Alright, so I do 4x times x is 4x squared. 5 times x is 5x. 4x and a negative 2 is negative 8x because I'm multiplying. And then a negative 2 and a positive 5 gives me a negative 10. Again, that top left corner is my only x squared, so I have 4x squared. My diagonal has x's in both, so I have to do a negative 8x plus a 5x, which I'm left with negative 3x, and then minus 10. Okay, the next two examples have twists to them. The first one, number 4, is x minus 3 squared. It's important that we remember when we square something, it means multiply it by itself. So we are actually going to think about this as x minus 3 times x minus 3. Okay, so it's important that if I give you something with the square, you understand that it's written like this. And so now on each side of the box, I'm going to put an x and a negative 3, x and a negative 3. So that's a notation you'll need to know. X times x is x squared. Negative 3 times x is negative 3x. Negative 3 times x is negative 3x. And then negative 3 times a negative 3 is a positive 9. X squared is by itself. I have a negative 3x plus a negative 3x is a negative 6x, or you can do plus negative, and then plus 9. Alright, so that one was similar, but again, you had to recognize to write it out as x minus 3 times x minus 3. But now this next one changes it up quite a bit. You'll see that I have a quadratic, 2x squared plus x minus 3 times x plus 5. I just want to show you that the box model actually works no matter how many terms you have. So if I have 3 terms like this, I just need to make sure I make 3 columns or 3 rows in my box. So instead of just 2 things, I'm going to break it apart as 2x squared plus 1x minus 3. So now I'm going to actually have to find the area of 6 little boxes. This is x plus 5. But I'm still following the same strategy. I'm going to find the area of all 6 little boxes, and then I'm going to add those 6 boxes together while combining like terms. Now I have 2x squared times x. 2 times 1 is 2. X squared times x gives me x cubed. So that's good to know that if you multiply x squared times x, it's x cubed. Now if I go x times x, because that's this box, I get x squared. And if I get negative 3 times x, I get negative 3x. So you'll see I'm not changing my strategy. I'm still finding the area of all the little boxes by multiplying the length times width. I just have more boxes to fill in. So now I've got the 5x and the 2x, just the 5 and the 2x squared. 5 times 2 is 10, and then x squared. Then I've got the 5 times x is just 5x. And then I have a positive 5 times a negative 3. Positive times a negative is negative, and it's 15. Remember, once we have those boxes, even though there's 6 of them, I still need to add those 6 boxes together. And I do that by combining like terms. So I start with my upper left-hand corner, and I see that I have a 2x cubed. And remember, the only way I would add something to that is if there were other x to the 3rd powers or x cubes somewhere in my boxes, and there are not. So 2x cubed is the first term. And then I get to x squared, and I look through my box to see if I have any other x squareds. And I do right here. I have a 10x squared. You can see that they are on a diagonal together again. So I have a 10x squared plus x squared. Remember, that'd be like a 1x squared, so that gives me plus 11x squared. Now, I have an x, and so I look for other x's, and I do have another x here. So I'm going to do 5x plus negative 3x, which gives me plus 2x. You can see that those fall on a diagonal together as well. And then finally, I have the negative 15, and there's no other numbers to add that to. So you can see that we can use this for multiplying trinomials, it's called, when it has 3 terms as well. Last but not least, number 6, big picture-wise, I wouldn't necessarily give you the box. So when you see a problem that looks like this, highlight it. When you see a problem of this form, First, you need to recognize that you're asked to multiply it because of the parenthesis back to back. And then, once you recognize that, hopefully you'll start to remember that the method we're learning to be able to do that is the box. And since it's 2 terms times 2 terms, I would make a 2 by 2 box. And then I'd put the 4x and a minus 1 on top, and an x and a plus 5. So you will have to ultimately draw your own boxes, because those won't really be part of the problem. It's just a tool to be able to do this. So 4x times x is 4x squared, x times negative 1 is negative 1x, 4x times 5 is 20x, and 5 times negative 1 is negative 5. Add them up, I get 4x squared, add my diagonal, because they're like terms, 20x minus 1x is plus 19x, and then minus 5. So that's our lesson for today. To summarize, what tool do we use to multiply polynomials? We're going to call this the box method. What I want you to do now is take out your multiplying polynomials homework. That's what it says at the top. And I want you to work through some of these problems until 1 o'clock. At 1 o'clock, you need to come back to this folder and start your next videos, which are vertex to standard form. Okay? Just so you know, on your homework, numbers 1 through 4 are examples, like the beginning here where I give you the boxes. Numbers 5 and 6, you'll do like number 6, where I don't give you the box and you multiply. And then finally, 7, 8, and 9 are review of previous concepts, so those will be good to practice as well. Thanks, and keep working hard.